granniopteryx, granniopteryx. She knows the truth, she's linking every link.
Hello, I'm going to be talking astronomy today, and I am not a professional astronomer. I am what you might call an enthusiastic bystander. So I may be making mistakes. Don't rely on the information I'm giving you if you want to check something out. And if I have made a mistake, you can put the corrections in the comments. And if they're really serious, I'll pin it. And if it's really, really serious, I might take the video down. Anyway, I'm talking astronomy today because today is December the 19th. And I thought I'd remind you that today, the 19th of December 2025, 3I-ATLAS, the interstellar object currently blasting its way through the solar system at a low speed of 130,000 miles an hour and a high of 240,000 at one point. 3I-ATLAS will be at its closest point to us today. The comet, well, they call it a comet, but I think maybe we should find a better word for such things. Anyway, whatever it is, the comet that gate crashed our solar system a few months ago has been proceeding through the ecliptic plane at such a terrific speed that we can be absolutely certain of it not being captured by our sun's gravity. And after it's whizzed past the Earth, it'll head on to whiz past Jupiter and then out the other side of the solar system on its eternal journey to the stars. Despite its brief sojourn in our neighbourhood, 3I-ATLAS has caused quite a stir in the astronomical community, amateur as well as professional. But one professional who really stands out is Avi Loeb, a theoretical astrophysicist at Harvard University, and I'd say probably no slouch when it comes to making calculations. Professor Loeb has pointed out not that this is alien technology for sure, but that we can't ignore the possibility that it might be. Because by any cometary standards, it really is acting very weird indeed. Or at least it's acting in a way that stretches coincidence beyond what most people would regard as reasonable limits. So I'm just going to go through the list and you can reach your own conclusions. From the little I've heard about it, it seems to me that it isn't a comet. I mean, it seems to me more that it was a chunk of a planet that got blasted out into space by a massive collision with another planet. That would account at least for the speed. However, I'm going to list the 10 anomalies that Professor Loeb has pointed out. And the first one is, the forecast is that 3I-ATLAS is going to pass Jupiter in March, and it's going to go past that planet at almost exactly the point where Jupiter's gravity is cancelled out by the sun's gravity. Just a little bit further in, and 3I-ATLAS would have been captured by Jupiter and ended up being swallowed by Jupiter in tiny little broken up pieces, like what's happened to the comet Shoemaker-Levy. However, that's not going to happen to this one because 3I-ATLAS is being clever enough to stay just outside that gravity well, which, by the way, is called the Hill radius. So imagine the Hill radius like a balloon around Jupiter. If 3I-ATLAS crashed into that balloon, it wouldn't ever get out, but instead it's just glancing past the surface. You'll probably be, if you're at all interested in this stuff, you'll probably be hearing a lot about that Hill radius come next spring. Okay, 2. 3I-ATLAS is flying directly across the ecliptic plane of the planets. That's the first thing that Professor Loeb noticed. If we regard the planets as going around the sun in a flat circle, like they're going round a plate or like the hands going round a clock or something, 3I-ATLAS is just 5 degrees above that plate in a retrograde route. That is, it flipped around the sun clockwise, which you'll see the wrong way round, won't you, since the camera's doing it clockwise, rather than anti-clockwise, which is the way all of our planets go. All right. Number 3, non-gravitational acceleration. I did say its speed varies. When an object moves through space and it passes another more massive body, unless it gets captured, the swing around this other body gives the object a bit of a push, which is known as gravitational acceleration. This is expected of any comet, but in the case of 3I-ATLAS, it appears to have been doing most of its speeding up without this slingshot effect. Well, not one that Professor Loeb has identified anyway. Of course, there's another way of going faster if you're a comet, and that's by outgassing. OK, it's Christmas, and you can think of Brussels sprouts as much as you want. Just because it's an interstellar object doesn't mean we can't think of more, well, basic things. However, let's get back to the science now. When an icy comet comes near something warm, like the sun, for instance, the ice on its surface sublimates. That is, the ice turns into gas instantly without going through the intermediate stage of being a liquid, which is what we're accustomed to here on this planet at this sea level. This sudden spout of sublimated ice can give a comet quite a push. But there are predictable pressures resulting in predictable speeds. 3I-ATLAS, so I have managed to understand, is going much faster than we'd expect from a bit of sublimated gas. It's going even faster than Aunt Edith from the table after Christmas lunch. All right. Number 4, 3I-ATLAS has been doing small course changes, which is not entirely unknown in comets as well. But the way 3I-ATLAS has been changing course is not explainable by typical outgassing, or by Aunt Edith. Number 5, comets have tails. We all know that. That is, bits of comet pushed out and backwards by the solar wind. And that's called the anti-sun tail. And sometimes comets also have a small sunward tail, and they're particles that are attracted out of the front of the comet by the sun's gravity. But that's usually very small. In this case, the sunward tail of 3I-ATLAS is just huge and cannot be explained by the physics of comets that we know about right now. However, I have to keep reminding you, this isn't a comet we do know about, and it might not even be a comet. Comets also often emit very visible jets of gas and dust shooting out from the nucleus. Usually these jets point away from the sun, as they're also carried backwards by the solar wind. However, 3I-ATLAS has jets going out in straight lines, and as for the tails, both the sunward and the anti-sunward tails, they're also very narrow, straight and disciplined. None of its emissions, either sublimated gases or standard tail, none of them, it seems, is spreading out with distance like a proper cometary tail or a jet would. I mean, we're all accustomed to the picture of a comet, which generally, graphically, it's shown like a sort of ball and then something coming out and then the tail spreading out like a fan behind it. That's not happening with 3I-ATLAS. They're all more or less straight. And as if that weren't puzzling enough, even more inconveniently for our present science is the discovery that 3I-ATLAS is rotating. Now, imagine a jet, a display jet, flying at tremendous speed and emitting a red, white and blue smoke trail behind it. But the smoke trail isn't spreading out in the air like smoke trails do. It's staying in a dead straight line behind the plane. Now, you'd think that was strange, wouldn't you? Now, try to imagine what that smoke trail would look like if the jet were rotating. Well, the tail of 3I-ATLAS isn't doing that. It appears to be the same old straight line all the way along, and that goes for the jets as well, which is a little strange. Number 6, 3I-ATLAS has an unusual chemical composition, and that's not so peculiar when you consider that it's from another solar system and perhaps even from another galaxy. And it might have been travelling for billions of years. But it really does have a very odd composition. Well, I just sneezed. As my mother said, when you sneeze when you're saying something, it means it's true. OK, 3I-ATLAS, a very odd composition. It's absolutely stuffed with CO2, but very little water, and appears to be mostly nickel with no iron. In this part of the galaxy, any natural occurrence of nickel means iron is there as well. That's just the way things are. It's like the BBC and lies. You just can't have one without the other. But not in the case of 3I-ATLAS. Nickel everywhere, and not a scrap of iron. Well, I think there is a little bit of iron, but not that you'd notice it very much. Number 7, 3I-ATLAS has an extremely unusual polarisation. That is, the light interference of its coma shows a surprisingly deep negative polarisation. Our local homegrown comets have usually negative polarisation as well, but it switches to positive when it gets to a certain point. Not with 3I-ATLAS. Those studying 3I-ATLAS can't work out for sure why this polarisation is so different, but they're suggesting that the grains that make up the coma might be larger than the ones we get around comets hereabouts. Or perhaps the grains are made of something we weren't expecting. Number 8. When we first saw 3I-ATLAS, its coma was reddish, but it seemed to go blue as it approached the sun, and then when it emerged from behind the sun, it was distinctly green. And now apparently it's turning red, at least according to the amateur astronomers whom I have been following. One of them is Ray's Astrophotography, and I would very strongly recommend him. And he's probably the best for this if you're interested in this sort of thing. Number 9. 3I-ATLAS has what has been described as a heartbeat-like pulsation in brightness every 16 hours. Of course, that, I suppose, has to be associated with its 16-hour rotation period. And number 10, it's losing colossal amounts of mass. And yet it isn't breaking up. While I've been following this saga, every so often someone says, "Is 3I-ATLAS breaking up at last?" But it never does. Well, not until now anyway. And it's emitting X-rays all the way round to roughly the distance of the Earth to the Moon. Now, it's an object they reckon it's probably about 5 miles wide. They don't know for sure. They're making that estimate. And you know, to have X-rays coming out from the Earth to the Moon sort of length from a 5-mile wide object. It's quite strong, isn't it? Professor Loeb says that all of these anomalies are most likely just the strange results we're getting from an object coming from an unknown solar system and, as I said, perhaps even an unknown galaxy. But he adds that all these anomalies together, particularly the route it's taken, he's very impressed by that, the fact that it's going past all these planets and practically a sort of flyby. He thinks that route he's taken through our solar system should at least make us stop and think, at the very least to consider the possibility that it might be an artificial construct of some sort. And that's it. That's as much as I've been able to discover for the time being. Meanwhile, today, as I remind you, the 19th of December, is a very special day, whatever 3I-ATLAS is. I was going to suggest you look at the virtual telescope project, but would you believe it? It's raining and the virtual telescope isn't working now, won't be working for a few hours. So just look out of your window towards the constellation Leo, which in the Northern Hemisphere is rising in the east. And sort of going a bit south. Look out of your window towards the constellation Leo and salute a visitor. No doubt there have been many others throughout the history of this planet, but we didn't know about them because in our 7 million year history as hominids and our 500,000 year history as Homo sapiens, we lacked the scientific knowledge and the equipment to be aware of such things. That makes us among the most privileged hominoids that have ever walked this earth. And we shouldn't ever forget that. All right, till next time. You can help my channel by subscribing and clicking the notification bell. That's quite important. And by sharing if you're so inclined. Links to my other channels and to donation methods are in the description. But the best way you can help is simply by clicking like and notify. Thank you.